Okay, we're going to start off by looking at what happens when there's a GCF, but our leftovers are still factorable. So 3x squared, or cubed, sorry, 3x cubed plus 15x squared plus 18x. Who can tell me what our GCF is? 3x. We factor that out, and that leaves me with x squared plus 5x plus 6. So now we need to check to see if that next piece is factorable. So we're looking for the factors of 6x squared to add to 5x. I prefer writing it this way so that I can look at my factors of 6 and see which pair is going to add up to 5. And then I know that this will be split into 2x and 3x. If you're one of those people who is liking the box method, remember you would be putting in x squared and 6 right here, and then filling in the 2x and the 3x right there to find your GCF. But we're going to take this now and factor it into x and 2 and 3, and they're both positive. Do not lose the 3x that we pulled out, because if we were to multiply it all back together, we would need all of the pieces, not just the last piece. Okay, here's a try it for you. Make sure you can do this. Raise your hand if you are struggling. Somebody can come around and help you. Who can tell me what GCF we needed to pull out? Okay, that left us with x squared minus 7x plus 10. And what were the factors that multiplied to 10 and added to negative 7?
2 and 5.
So 2 and 5, if I multiply those, they make 10, but if I add them,
-2, -5.
negative 2, negative 5. Right. Let's do one more, try it. 6x cubed plus 30x squared plus 24x.
Good day, huh?
No.
What was the GCF? That left us with x squared plus 5x plus 4. Don't lose your 6x. What were the factors that multiplied to 4 and added to 5?
Yeah, 36 divided by 6.
That's
30.
Oh, sorry, my bad. I could see where that would be confusing. Should be 30.
4.
1 and 4, both positive, right?
Those were in the.
Right. Moving on to the next thing that we're going to learn today. Let's look at 6x squared plus 11x plus 4. Okay, and we're going to remember that what goes in the top of this? Anybody know?
First times the last.
The first times the last. And when we had just x squared, it really didn't make that big of a deal because we were just talking about factors of 4. But this time we're actually talking about factors of 24x squared. There's Kaden. I can't find my mouse to let him in. So we're still adding to 11x. But now we want the factors of 24. So that was the a times the c, right?
3 and 8.
So 3x and 8x are the factors. If you like to do it like this, x squared and 11x, and you like to list 1 and 24, 2 and 12, 3 and 8, 4 and 6, to find the pair that adds to 11, you can do that. Okay. Now let's talk about how this works with the box. And this is a place where a lot of people are like, oh, I think I do like the box. Didn't need it before, makes a lot more sense here. 6x squared and 4 go here. And we're splitting that 11x into 3x and 8x. And then we can look for the GCF of each column. So the GCF of the first set is 2x. And then 3x and 4, the GCF is just 1. And then top to bottom, I have 3x as my GCF and 4 as my GCF. So my factors are going to be the 3x plus 4 and the 2x plus 1. Some people really like this box strategy because it keeps things really organized and it's quick to work through. I am, however, going to teach you about factoring by grouping because that is what most of the Algebra 2 teachers focus on. So I will teach that. This middle term right here, we really are splitting it into 3x and 8x. Then we're going to drop down our 4 and drop down our 6x squared. So for factoring by grouping, we're going to group the first two terms. That needs a plus on it, just so we know that that's a separate term. And our second two. And the GCF of that first group is what? 3x. And when I take that out, I'm left with 2x plus 1. The GCF of the second one is a positive 4. That leaves me with 2x plus 1. Now, if you can see that this is multiplication, the 3x times that stuff in the parentheses, and the 4 times that stuff in the parentheses, you really see that what we have is 2 terms. It looks like a lot more than 2 terms, but because multiplication is all one term, then we really only have 2 terms. But what do both of those terms have in common? A 2x plus 1. So we can pull out the greatest common factor of 2x plus 1. And then we're left with 3x plus 4 as our leftovers. Let's do one more example together. Let's start with 10x squared plus 17x plus 3. 10x squared plus 17x plus 3. So we're looking for factors of 30x squared to add to 17x. 1 and 30, 2 and 15, 3 and 10, 5 and 6. That adds to 17. So we're splitting it into 2x and 15x. If I want to do the box method, my first and last terms gonna go here, 10x squared and our positive 3, and we're splitting the other term into 2x and 15x, and you're gonna pull out the GCX of those. If you want to do factoring by grouping, then we're going to put the 2x and the plus 2x and the plus 15x into the equation and drop down the positive 3 and drop down the 10x squared. We will group the first two together and group the second two together. Our GCF of the first one is 2x. That leaves us with 5x plus 1. Our GCF of the second one is a positive 3. And that leaves us with 5x plus 1. Both of them have a 5x plus 1. And we are left with 2x plus 3. Just out of curiosity, how many of you prefer the box method? Anybody? A couple people? All right, here's where you're going to try it out on your own with a try it. Two x squared plus x minus 21. If you need help, raise your hand. There is someone who can come around and help you. If you're at home and you need help, let me know. I can try to work with you. What am I multiplying to, just so we are all on the same page? Minus 42x squared. And we're adding to 1x. Okay. Okay, I've got you started. Whether you're going one way or the other, you should be able to look at this and determine.
Question, is this school tomorrow?
Yes, at home.
One of my teachers, his teacher said that tomorrow that we would have to run on the track, 7 miles. Or, but Wednesday,
Tomorrow is Wednesday.
but
He's probably joking. 7 miles is quite a lot of miles.
So just like normal, Wednesdays at home. Just like our regular schedule, Wednesday at home. Tuesday, Thursday are early release. This day, or if you get,
Friday's a full day.
and Friday's a regular day. Okay, so when we group the first two together, we pull out what? And that left me with my second pairing. I pull out +7, right? And that leaves me with, so that means we have a matching x minus 3 and our leftovers 2x plus 7. Use the box method, you pulled out a 2x and a 7, and you pulled out an x and a -3. How many of you use the box? Okay, there's a couple people who didn't do anything at all, so we won't count that. But a couple people use the box method, a couple people use the factoring by. Okay, we're now going to talk about a couple of special cases. And the first one we're going to talk about is a perfect square trinomial. Perfect square trinomial. First thing we want to know about our perfect square trinomial is, are the first and third terms perfect squares? Are the first and third terms perfect squares? So perfect squares are things like x squared or 9 or 16 or 25. They can be square, you can take the square root and it comes out perfect. No leftovers. Okay, the second thing that you need to ask yourself is, does the middle term equal 2 times A times B? That actually should be a question mark here. And then our last step, if it meets both of those requirements, then we write the first term and third term as a binomial squared. Okay, so we're looking at this form. We have a squared plus 2ab plus b squared. So here's the example we're going to look at. X squared plus 14x plus 49. Okay, is the first term a perfect square? Yeah, we've got x squared, so the square root would just be x, right? And the last term, what's the square root of 49?
7.
7, so that's really 7 squared right there. Is the middle term 2 times x times 7? So we need to check for step 2, 2 times x times 7, that equals 14x, right?
Yeah.
So that does work. So then our step 3, which is just to write it out, is going to be x plus 7 squared. Now this is a cool shortcut to know. You can still factor a perfect square trinomial in another way without knowing this shortcut. You can still get an answer. But the shortcut, if you can see it, because you don't actually have to write down everything we just wrote down, you can just do it. Makes a nice shortcut. Yes.
When you want to put x plus 7 squared at the beginning, so it's easier to evaluate.
Pardon, say that again.
When you want to put it before x squared and 7 squared because it'd be easier to evaluate.
Put,
Okay.
so, yeah, I mean, it depends on where you're going with it. But when we're talking about just getting it factored,
Okay.
so let's do another example. And I'm just going to erase this first part right here. So we have the rules left on the other side. So you can kind of see what the expectation would be for writing this down. So if I've got, let's go with 9x squared minus 30x plus 25. The first term, what's the square root of the first term? 3x, right? What's the square root of the last term? 5. And then if I did 2 times 3 times 5, does it equal 30? Except for we have a negative here, right? So we're going to put a negative there and right squared. So really, that's how simple it should be. If you can remember and you notice that it's a perfect square trinomial. So you notice it's a perfect square trinomial. Quite simple to just hop in and factor it that way. Here's your try it. Actually going to give you 2 of these. Try it number 1, or A, will be 4x squared plus 12x plus 9. And try it B, will be x squared minus 8x plus 16. That's not very good writing right there.
Yeah. 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 Yeah.
For anyone who's on
Oh,
algebra.
yeah.
But it'll also help you.
Yeah.
Sometimes you think above where we're at.
Yeah.
I do the same thing. Ms. Fisher has to pull me back.
Something special.
Okay, what's my first one?
2x plus 3 squared.
And my second one?
X minus 4 squared.
Okay. Everybody ready for me to erase? We have one other thing we need to talk about today, and that is difference of squares. What does difference mean?
Change.
Okay, mathematically, what is a difference? It's an answer to what kind of problem? Difference is answer to a subtraction problem, right? We have sum, we have different, we have quotient, we have product, those words. Difference means subtraction. So for this, step one is to ask yourself, is it a binomial? What's a binomial? Two terms. Is it a binomial? Second question to ask yourself, is it subtraction? Third question we're going to ask ourselves, are both terms perfect squares? If that's all true, then we can factor as a minus or a plus b and a minus b. Or you could write a minus b, a plus b. Same thing, okay? One is positive, one is negative. Let's look at an example of how that works. Is it a binomial? Yeah, I got x squared and I got -9. That's it, two terms. Is it subtraction? Yes. Are both terms perfect squares? Yes. So then I'm just going to write it like this, and x, and 3 and 3, and positive and negative. Let's do another one. 4x squared minus 81. Is it a binomial? Is it subtraction? Are both terms perfect squares? Two x minus 9, 2x plus 9. Ta-da. Okay, here's your try-its. I'm going to give you a couple of try-its. X squared minus 64. That's your first one. And your second one is 9x squared minus 100. How's it looking out there, Fitz? Are they getting it? What's my first one?
X minus 8, x plus 8.
Somebody else give me my second one. Ta-da! Okay, I am going to give you one to factor here. I want to see if you can tell me how to do this one. Put all the pieces of things you know together. what would be the first thing that you would want to do here?
Factor.
Take out the 3.
Pull out a 3. Is that all that's in common?
3x.
Okay, we'll pull out a 3xy. And that will give me x squared minus 4y
Y.
squared. Am I done?
Differences with
Now I can do difference of squares. X and 2y and 2y plus and minus. Awesome job, you guys.